Hello, Hemant, your voice is not clear to me.
Sir, hello, sir. Hello, sir.
Yeah. Fine now. Yes, is the screen visible to you?
Yes, the screen is visible, sir. No issues.
Screen is visible. Fine. So till now we have seen the electric field due to uniformly charged disk. After disk, hmm, electric field due to sphere, that also we have seen. Now next topic is electric field lines. Yes, now tell me, what do you understand by electric field lines? Till now you must have studied what are the electric field lines. So can you tell me, what do you understand by electric field lines?
So then we can say they are the imaginary lines. We can say
Yes, they are imaginary lines, but
from
what do they
positive charge
represent?
to negative.
Yes, good. What do they represent?
We can say the direction of electric field. We can.
Direction electric. They are electric field lines. Their name is electric field line. But what do they represent? They are representing force. Force on 1 coulomb charge and its direction. Getting it? How much force will be appearing on a charged particle when it will be kept in the electric field at that particular point. This is defined as electric field, and electric field lines are nothing but a representation of electric field, is it not? Okay,
So
so
your
these are
voice
also
can
called as
again too
lines
low.
of force. Why the voice is lower? I don't know. I have taken other classes also. Uh,
Amma,
just a
Amma,
minute.
a Bluetooth डब्बा जिसको आप
Yes, is
speaker,
it clear now?
a Bluetooth speaker.
Hello, is it clear now?
So now it is clear, sir. No issue.
So,
So now it is clear, sir. No issues.
so electric field lines are nothing but lines of force. These are imaginary lines of force which represent the direction and magnitude of force at a particular point charge when placed in the electric field region. Okay, so you can write down the definitions. First definition is they are imaginary straight or curved lines, or we can say the paths along which a positive test charge is supposed to move when free to do so. Okay, or we can define them as an imaginary line, the tangent to which at any point represents the direction of electric field at that point.
Hmm.
Okay, now what are the properties? Lines of force originate at positive charge and they end at negative charge.
Negative.
Okay, for this is the first property.
The first
Second
property.
property, they never
Second
intersect
property,
each other.
they never
Why?
intersect.
Because electric
Why?
field must not
Because
have two
electric field must
directions
not
at
have
any
two
single
directions
point.
at any single point.
And just now,
And just now,
hello, yeah, am I audible?
hello, am I audible? Sir,
Hello,
you're audible, sir. No issues.
fine,
Sir,
fine,
you're audible, sir. No, hello, sir. Yes.
fine. Just keep saying something, yes or no,
Just
so
keep
that I
saying
will
something,
be able
yes
to
or
know
no.
that you are
Yes,
here
sir.
in
Yes,
class
sir.
or
You
it's
will
not
know that you are
disconnected.
here in
Okay.
class or not connected, okay? Yes, sir. Yes.
Now, third is they don't form
Third
closed
is
loops.
they don't form closed loop.
Why they don't form closed loops? Because
Why
it
they
is their
don't form closed
definition that they
because
start
it is
from
their definition
positive
that
and
they
end
start
at
from
negative
positive
charge.
and end at negative charge.
Okay.
Yes,
Now,
sir.
Fourth point is the number of field lines
Fourth
per
point
unit
is
cross
the
section
number of
area
field lines per
will
unit cross
represent
section
the
area
magnitude of electric
will
field.
represent the magnitude of electric field.
It means what? The
Means
parallel
what? Parallel
the parallel field lines will represent
parallel field lines will
constant
represent
electric field.
constant electric field.
But if the number of lines means the
If
density
the
of
number of lines
lines per
means the
unit area
density
is
of
decreasing or
lines per
increasing,
unit area
then
is
it means the
decreasing or
electric field
increasing,
will also be
then
decreasing
it
or
means the
increasing.
electric field will also be decreasing or increasing.
Okay, see these two diagrams. In this
Okay,
diagram
see
on
these
the
two
left hand
diagrams
side,
in this diagram on the left hand side.
the electric field lines, they are
The
concentrated
electric field lines they are
initially
concentrated
and then they are getting separated
initially
by
and
some
then they are
distance.
separated by some distance.
Okay, and because these lines are getting separated, it means
Because
what?
these lines are getting
It means
separated, it
that
means what?
the electric
It means
field is
that
weaker
the
ahead
electric field
and it
is
was
weaker
higher
ahead and it was higher
initially.
initially.
Okay, got this point?
Yes, sir.
Got this point?
Sir, got it, sir.
Now,
Now,
next point.
next
Fifth
point.
it is number of field lines
Fifth it
from
is
a charge
number
are
of
drawn
field lines
proportional
from
to
a
the
charge
magnitude of
are
charge.
drawn proportional to the magnitude of charge.
Means what? If the charge is of 1 coulomb
Means what?
and we are drawing
If the
two
charge is of
lines
1
of
coulomb
force,
and we are drawing
then
two
from
lines of
4
force,
coulomb charge
then
we
from
must
4
draw
coulomb charge
4
we
times
must
to
draw
that of 1
4
coulomb.
times to
Means
that
8
of
lines we
1
must
coulomb.
draw.
Means 8 lines we must draw.
Okay, 4 into 2, 4 to the 8. For 1
Okay,
coulomb
4
there are 2
into 2,
lines.
4
Then
to the
it
8.
means
For 1 coulomb there
for
are 2
4
lines.
coulombs
Then
there
it
will be
means
8 lines.
for
Okay,
4 coulombs there will be 8 lines. Okay.
Yes, sir. So we can take if we
again,
take for 1 coulomb 5 lines,
Again,
then for 4 coulomb we should take 20 lines, sir.
yes.
yes.
Okay, so
Sir,
now
for one
field
coulomb
lines
we
are
should take only 2 lines always.
Field lines are
yes. What did you say? No. I am
yes.
just
What did you
right now.
say?
I am just saying
No.
for the
I am just
number of
right now. I am just saying for the number of
Yes, sir.
and the number of field
and the
lines. It is up
number
to
of
you
field lines.
how much
It
field
is up
lines
to
you
you
can
how
draw.
much field lines you can
Okay,
draw.
there is
Okay.
no particular
There,
rule or set of
there is
rules to
no
draw the
particular
number of
rule or
lines.
set of rules
That
for the
how much
number of
number,
lines.
only proportional number of
How much
lines we
number?
can draw.
Only proportional number of lines we can draw.
Okay, so yes, you can draw, but
So
it's better to draw
yes, you can
two
draw, but
lines
it's
only.
better
Okay,
to draw two lines only. Okay.
getting it? Shall I move
Getting it?
ahead?
Sir,
Shall I move ahead?
yes, sir, we can go. Sir.
Fine. Now, extension of this
Now,
property
Ma,
is the field
extension of this
lines must
property
be drawn
is the
symmetric
field
about the
lines
line
must be
joining
drawn
two charges.
symmetric about the line
Means
joining
whatever
two
field
charges.
lines we are going to draw, they must be
Whatever field
symmetric
lines we are
about
going
the
to draw, they must be
axis.
symmetric
Axis
about
or
the
what?
axis.
Line
Axis
joining
or
the
what?
two charges,
Line
positive and
joining the
negative.
two charges,
Okay,
positive and negative. Okay.
getting it?
Getting it?
These lines they
These
end or
lines
start
they
normally
end or start normally
from the surface of a conductor.
from the surface of a conductor.
If there is a conductor, then these
There is a
electric lines
conductor,
of
then
force will
these
start
electric lines of
perpendicularly
force
from the
will
surface
start
of the conductor.
perpendicularly from the surface of the conductor.
Fine, got it?
Fine,
Next
got it?
point now. Point number 7.
Next point. Point
Electric
number
field
7.
lines will never enter
Electric field
inside
lines will
a
never
conductor.
enter inside a conductor.
Electric field inside a conductor
Electric field
is
inside a
always
conductor
0.
is always zero.
sir, why, sir? Answer there will
Electric
be zero like that.
Electric
electric field inside a conductor is 0. Why?
electric field inside a
We
conductor
know
is
that
zero. Why? We know that
electrostatic.
Because charge does not exist.
electrostatic.
Yes. What are you saying?
Yes. What are you saying?
Sir, because charge does not exist like that, we can say the reason, sir.
Uh, not because of charge, because the electric
Not
field
because of
lines will be
charge, because
cancelled
the electric
inside the
field lines
conductor.
will be cancelled inside the conductor.
Okay, means charges will be spread all over
Means
the body of the
charges
conductor,
will be
all over the
spread all over the
surface,
body
and
of the
these
conductor, all over the
field,
surface,
electric field,
and
because of
these
these charges,
field,
it will
electric
cancel
field because of these charges,
the
it will
electric field due
cancel
to another charge, opposite charge,
electric field due to another charge,
inside the
opposite
same
charge,
conductor. Hence, electric field will
inside the
always
same
be zero.
conductor. Hence, electric field
But
will always
just
be
before this property, we have
just
studied that
before this
electric
property. We
field
have
lines
studied
end
that
or start
electric field lines end
perpendicularly
or start
on the surface of a
perpendicularly
conductor. So, if
on
a
the surface of
spherical
a conductor.
conductor is
So,
kept,
if a
then
spherical
the
conductor is
electric field
kept,
lines will be
then
distorted
the
like
electric
this,
field lines will be
as we are
distorted like
seeing
this,
in this figure.
as we are seeing in this figure.
Okay,
Okay.
Yes, sir. Okay, sir.
got it now.
Got it now.
Hmm.
Sir, got sir.
Next is near field
Next,
and far
near
field. This is
field
a very good
and
concept.
far field. This is a very good
Near field
concept.
and far field concept is that
Near field and far field concept is
when
that
two charges are there, let us
when
say
two
that
charges are there,
plus
let us
2
say that
coulomb charge plus
plus 2
2q coulomb charge is
coulomb
there,
charge plus
and
2q
minus q
coulomb charge
coulomb
is there,
charge is there.
and minus q coulomb
So we
charge
know
is
that
there.
if we are drawing 4
So we
lines
know
from
that if
minus
we are
q,
drawing
we have to
four
draw
lines from
8
minus
lines
q,
from
we
plus
have to
2q.
draw 8 lines from plus
Getting it?
2q.
If we are drawing 4
Getting it?
lines from
If we are drawing
minus q,
4 lines
then we
from
have to draw
minus
8
q,
lines from
then we
plus
have to
2q.
draw 8 lines from plus
It
2q.
means what?
It means what?
The field lines must be like
Field
this.
lines must be
Okay.
like this. Okay.
But this is when we
But
are looking from a close
this
point
is
of
when
view.
we are looking from a
From a
close
farther
point
point
of
of view, like from
from a
1
farther
kilometer
point of
distance,
view, like from
we
one
will
kilometer
see these
distance.
2 point charges
We
as a
will
single
see
point.
2 point
Like
charges
these
as a
two
single
points are
point.
there.
Like these 2 points are there.
Let us say if you are going very
If you
far,
if you are going
then
very
these
very
two
very
points
very
will
far,
become one.
then these two
Okay,
points
you will
will
see
become one.
them as one single point.
You
Like
will see them as
several
one
stars are
single
there
point.
in the
Like
sky, which
several
are
stars
not
are
even a
there in the
single
sky,
star. They are
which are
cluster
not
of
even a
stars.
single star. They are
There
cluster
is
of
one
stars.
Kritika nakshatra.
There is a Kritika nakshatra.
It has several. It is a group
It
of
has
stars actually.
several. It is a group
But
of stars
to
actually.
our naked eyes,
But
it is only a single
to our
star.
naked eyes, it is only a single star.
So why it is happening?
So
Because of
why it
farther
is happening?
distance.
Because of
The
farther distance.
stars are kept very far away from each
Stars
other.
are kept
Similarly,
very
here
very far away from.
these 2 point
Similarly,
charges
here
will appear
these
as a
2 point
single charge.
charges will appear as a
Single
single
charge whose
charge.
magnitude is what?
Single charge whose
Only plus
magnitude
q.
is what?
So when we see it from
Only plus.
far,
So when we
from
see it from
uh,
far,
a
from
distance, from a
uh,
great distance
a
away,
distance,
then what will happen?
from a great distance
Total charge
away,
will be
then what
plus
will
q,
happen?
and
Total
it
charge will
will
be plus
emit
q, and
4 electric
it
lines
will
of
emit
force
4
in
electric lines of
symmetric
force
directions.
in symmetric direction.
Okay, from far away, this should be the diagram
From
as
far away,
observed from
this
the
should be
far.
the diagram as
Now,
observed
as
from
the
the
field
far.
lines must be
Now, as
symmetric,
the
therefore
field
the
lines
correct
must be
representation
symmetric,
will be
therefore the
this.
correct representation will
This
be
is the
this.
correct representation as
This
seen
is the
from
correct
far.
representation as
8
seen
field
from
lines emitting,
far. 8 field
emitting
lines
out, but
emitting,
only
emitting
4
out,
are
but
getting
only
outside.
4 are
Got it
getting
now?
outside. Got it now?
Sir, got it, sir.
Take it down. Draw this down. This is
Take it
important.
down.
From where
Draw
you need
this
to take
down.
it
This
down?
is important. From where we need to take it down?
From this point only, sir. Near and far field. Copying, sir.
Fine. Take it down.
Fine, fine. Take it down.
Voda. Sir, copy it, sir.
Hello,
Hello?
hello.
Hello?
Yeah, am I audible?
Am I audible?
Sir, you're audible, sir. Copy.
Now,
Sir, you are not audible, sir.
is it not? Am I not audible now?
Is it not? Am I not audible now?
Sir, your voice is breaking, sir.
Yes, it is raining here heavily, so it might
Yes,
break.
it is raining here heavily, so it might break.
See now,
So means,
see this question.
See
This
now,
question is of
see this question. This question is of.
can you see this question?
See this
Can you
question?
tell me which charge is greater than
Can you tell me which charge is greater than
the another charge? Q1 is greater than Q2,
another
Q1
charge?
is less than
Q1 is
Q2,
greater than Q2,
or both
Q1
are
is less than
equals.
Q2. So both are equals.
sir, Q2 greater than Q1, we can say.
Q2 is greater than Q1, is it?
Q2 is greater than Q1, is it?
Yes, sir.
Yes. Why?
Yes. Why?
So because if you can see the figure, the electric lines are rapidly they are attracted by Q2, we can say.
Very good, very good. The lines of
Very good,
force
very
are
good. The
rapidly
lines of
converging
force
towards
are
Q2.
rapidly converging toward Q2.
It means what? It means
It means
the
what?
lines of
It
force are
means
more dense,
the lines of force
or
are
we can say
more dense,
densely packed at
or we
Q2
can say
rather
densely
than,
packed at Q2 rather than
Q1.
yes, other than Q1.
yes,
So
other than Q1.
ultimately
So
we are having what? Q2
ultimately we
greater
are
than
having what?
Q1.
Q2 greater
We
than.
can first solve it like
We
this
can
also. We
first
can complete the
solve it like
diagram
this
and then
also.
we
We
can
can
compare.
complete the diagram and then we can compare.
Because a property we have studied, in that property
For
we
the
have
property
studied
we have studied, in
that
that property we have studied that
electric lines of force must be symmetric
electric lines of
about
force
the
must be
axis.
symmetric about the axis.
Okay.
Yes.
Okay.
Similarly, another question.
Similarly, another question.
Q1 and Q2 are the two charges.
Q1 and Q2 are the two
Find
charges.
the ratio Q1 by
Find
Q2
the
if the
ratio
field lines
Q1 by
between
Q2
them are
if
as
the
follows.
field lines between them are as follows.
Yes, what will be the answer?
What will be the answer?
Sir, Q1, Q2 are any two charges. Find Q1 by Q2 if the field lines between them are as follows. Naina, ito net issue. Hmm? Hmm. ఏదో ఒకటి టకాటకండి. So 4 we can write now. So what? So 4 we
4
can tell us.
Q1 upon Q2 is 4, right? How?
Q2 is 4,
How
right?
are you getting 4?
Yes.
How are you getting 4?
So we can say that if the two electric field lines are getting 4 to Q2, then there's a property now. So there should be n times that of this electric field line. From that, we can get the ratio.
So one property
One
is there
property
that electric field lines must be
is there that
drawn
electric
in
field lines must
proportion
be
with the
drawn in proportion with the
magnitude of
1
this
cool.
charge.
magnitude of this
Charge.
charge.
Yes, sir.
Yes, yes, yes. So
So by observing
here
the electric field line, we can say
magnitude of charge
proportional
we
to
do
A.
Here,
not.
magnitude
Yeah,
of
yeah,
charge
yeah,
we
very
do
good.
not.
It means what
Yeah,
Q1 is
yeah, very good.
proportional to
It
8
means
and Q2 is
Q1 is
proportional to
proportional to
4.
8 and Q2 is proportional to 4.
4. Yes.
Therefore, the ratio will be what? 8 by
Therefore, the
4.
ratio will
Answer
be
is
what?
2,
Yes.
8 by 4. Answer is
not
2,
4. Okay,
not 4. Okay?
Yes.
got
The
it now?
screen is not visible, sir.
Got it now?
Now see this question.
Now see
This
this
question
question.
is of JE previous year.
This question is of JEE previous year.
స్క్రీన్ కనపడట్లేదు అయ్యా
Choose the
ఏం
correct
చేయాలి
depiction of the
Choose the
field
correct depiction
lines.
of the field lines.
These 4 field lines are drawn.
These
Can you see the
4
question
field lines
properly?
are drawn. Can you see the question properly?
Yes, am I audible?
yes sir I can see sir
Yes, am I audible?
yes sir I can see sir
In this
sir I
question,
can see sir
this
In this
yeah,
question,
cylinder is
the
given to
image is
us,
blurry sir.
cylinder is given to us,
and that cylinder is divided in two
and that
halves.
cylinder is
Means a single
divided in
cylinder is
two
there, but
halves.
half of the
It's
cylinder
a
is
single cylinder, is it? But
positively charged and
half of the
half of it
cylinder
is
is
negatively
positively
charged.
charged and half of it is negatively
Choose
charged.
the correct depiction of field lines 1,
Choose the
2,
correct
3, and
depiction of
4.
field lines 1, 2,
Here
3,
we
and 4.
must notice one thing,
Here
that
we
there is no
must
net
notice
charge
one thing,
inside
that
the
there
cylinder.
is no net charge inside
There
the
is
cylinder.
no net charge inside the
There is no net
cylinder.
charge
Net charge
inside
is
the
0.
cylinder.
It means
Net
what?
charge is
When
0.
net charge is 0,
It means
then
what?
no
When net
field
charge is
line should
0,
emit
then no field line
from
should
the
emit
cylinder.
from the
No field
cylinder.
line should get
No field line should get
out from the cylinder. All the
out
field
from the
lines
cylinder.
should be
All the
starting
field lines should be
and
starting
ending within the
and
cylinder.
ending within the
Okay, in
cylinder.
first diagram, option
In
A, field
first
lines are
diagram,
going
option
out
A, field lines are going out
and coming in as well.
and
They
coming
are
in as
symmetric,
well.
but
They
the
are
field,
symmetric,
no
but
field line should emit, no field line should
no field
go
line should emit,
inside,
no field
because
line should
it
go
is
inside
neutral
because
as a whole.
it is neutral as a
In
whole.
second case, it is obviously wrong because
In second
negative
case, it is
charge
obviously wrong
is
because
shown to
negative
emit
charge is
field
shown
lines, that is
to
false.
emit field lines, that is false.
In third case, again the electric field lines are
Third
going
case,
out
again
and
the
again
electric
they
field
are
lines are
coming in.
going out and
They
again
are
they are
not forming
coming in.
closed loops here,
They are not forming closed loops here.
but electric field lines
Electric field lines
are what? Electric field lines must
are what?
start from positive
Electric
and
field lines
end at
must
negative.
start from positive
So
and
the
end
only
at
option
negative.
negative
which
yes
correctly
So the
depicts
only
this is
option
D
which
option.
correctly depicts this is D option.
Got it now? Do you want to take it down?
Got
This
it now?
question?
Do you want to take it down? This question?
yes sir I will take down
Fine, take it down.
I take it.
ఒకటి ఇక్కడ మర్యాద వచ్చేది సార్ డన్ సార్
Fine. Now see this question. Next question is this
Now
one.
see this question. Next question is this.
Three positive charges are placed
Three positive
on
charges
vertices
are
of an
placed
equilateral triangle.
on vertices of an equilateral triangle.
Then,
Then
what is the correct depiction of the
what is
electric
the correct
field
depiction
lines?
of the electric field line?
Yes, now. What is the correct depiction of electric
Correct
field
depiction of
lines?
electric field lines.
sir can you show the fourth option sir
Yes, this is the fourth option.
This is the fourth option.
So option B is correct, we can say.
Option B for ball or D?
B for ball or D?
Sir,
Yes, which option
B
is
sir,
correct?
ball.
B for
Which option is correct?
B for
B
ball.
for
Bombay,
Fine.
sir.
B for ball.
Yes, Bombay is correct. How and
Yes,
why?
ball is correct.
Because
How and why?
field lines should
Because
not intersect each other.
field lines should not intersect
They
each other.
cannot form closed
Available
loops.
now.
They cannot form
In D
closed
option, they are
loops.
forming closed loops.
In D option, they are forming
In
closed.
C option also,
In
they are
C option
intersecting
also, they are
and
intersecting
they are forming a closed loop at the center.
and
This is
they are
not
forming
possible.
a closed loop at the center.
And
This is
in
not
A
possible.
option, they are starting
And
from
in A
positive and
option,
ending at
they are
positive,
starting
which is
from
not
positive
possible.
and ending at positive,
Okay, so
which is
only
not
B
possible.
option is remaining, which is
Only B option
correct.
is remaining, which is
Now, next is
correct.
motion of a charged
Now, next is
particle
motion of a
in a
charged
field line.
particle in a field line.
Now, see,
Now, see,
charged particle, whenever a charged particle is
charged
there
particle, whenever a
and it
charged
enters
particle is
a
there
electric
and
field,
it
what will happen?
enters
It
an
will
electric field,
experience a force.
what will happen? It
If
will
the charge is
experience a
positive,
force.
it
If
will
the charge is
experience a
positive,
force in the
it
direction
will
opposite
experience
to
a
that of
force
electric
in the
field.
direction opposite to
Why?
that of electric field.
Because positive charge will be
Why?
attracted towards
Because
negative charge.
positive charge will be
Simple.
attracted towards
So
negative charge.
positive charge will
Simple.
be attracted
So
towards the
positive charge
negative
will be
charge, means
attracted
it will
towards the
go in
negative charge,
direction
means it will
of
go
the
in
electric
direction
field, whereas the negative
of the
charge,
electric field,
it will
whereas
be
the
attracted
negative charge
towards the
will
positive
be
charge. It
attracted
will go in the
towards
direction
the
opposite to the
positive charge.
electric
It will
field.
go in the
Okay.
direction opposite to the electric
Now,
field.
what
Okay.
will be this force? We know
Now, what will
that
be this force? We
electric
know
field
that
is force on 1 coulomb charge.
electric
If
field
10
is
coulomb
force on
charge
1
will be
coulomb
placed,
charge.
then
If 10 coulomb charge will be
directly
placed, then
multiply. You will get the
multiply, you will get the
when you directly multiply, you will get the
multiply,
force
you
on
will get the
charge
force
q.
on
Whatever the total
charge
charge is,
Q.
just multiply it
Whatever
with
the
the
total
electric field
charge
at
is,
that
just
point.
multiply
Okay.
the electric field at that point.
So if
Okay.
electric field is constant, the force will be
So
q
if
into
electric
e.
field is constant, the force will be Q into
Clear?
E.
Is it clear?
Clear? Is it clear?
Sir, clear, sir. Clear, sir.
Now, if the electric field is known to
If
us,
the
charge
electric
is known
field
to
is
us,
known to
then
us, charge is
force is known to
then
us. If we
force
divide
is
it
known.
by
If you divide it by
if you divide it by mass
if
m,
you divide it by mass m,
then what will happen?
then what will happen?
If you divide it by mass m, you will get
Divide it by mass
force,
m, you will
total
get
force on the
force,
charge, total
force
force which is
on the charge. Total force which is
charge multiplied by the electric field. Okay.
charge multiplied by the electric field. Okay.
Hello, am I audible?
So, am I audible?
Sir, you're audible, sir. No issue.
Yes. Charge multiplied by the electric
Yes.
field will give us the
Charge multiplied
force.
by the electric field
And
will
when we
give us
will
the
divide it
force.
by mass, we will get what?
And when we will
Acceleration.
divide it by mass,
Total
we will get what?
acceleration we will get.
Acceleration. Total acceleration
Got it
we
now?
will get.
So
Got
this
it
is
now?
the
So this is the
expression for
expression
acceleration
for
of
acceleration
charged
of
particle because of electric
charged
field.
particle because of electric
This
field.
was the case when the charge
This was the
was
case
going
when the charge
perpendicular to the electric field.
was
Now, if
going
the charge is
perpendicular to the
moving
electric field. Now, if the
parallel to the
charge is
electric field,
moving
now if the charge is moving
parallel to the electric
perpendicular
field,
to the
now if the
electric
charge
field,
is
then what
moving
will happen?
perpendicular to the electric field, then what will happen?
Then, as soon as this charge
Then, as
enters
soon as
the
this charge
field region,
enters the
it
field
will be
region,
constantly dragged
it will be
towards
constantly
the
dragged
opposite charge. Means if the
towards
charge is
the
negative,
opposite charge.
it
If
will
the
be
charge is
dragged
negative,
towards positive
it
charge,
will
and
be
if the charge
dragged
is
towards positive charge, and
positive,
if the
it will be
charge is
dragged towards the negative
positive, it
charge.
will be dragged towards
Trajectory will
the
be
negative
same
charge.
as soon as the means
Trajectory will
as
be
long
same
as the
as soon
charge
as
is
the
kept same,
as long as the
electric field is
charge is
kept
kept
same,
same,
trajectory
electric
of the
field is
particle
kept
will
same,
be same.
trajectory
Okay,
of the particle will be same. Okay.
getting it? So now we will
Getting?
have
So
motion
now
in two
we will have
directions. in
motion
y
in two
direction as well
directions,
as in x direction.
in y direction as well
Because
as in
there
x
is no
direction.
force in x
Because
direction,
there is
there
no
will be
force in x direction,
no change in
there
the
will be
velocity in x
no
direction. But
change
in
in the
y direction,
velocity in
a
x
change
direction.
of
But in
velocity
y
will occur.
direction, a change of
Why?
velocity will
Because an
occur.
acceleration
Why? Because an
is being
acceleration
applied in y
is
direction.
being applied in y
Got it?
direction. Got it?
Therefore, what will happen? The velocity will
Therefore, what
increase
will happen? The velocity will increase
in positive y direction.
in positive y direction.
But in horizontal direction, x direction,
In
velocity will
horizontal
not
direction,
increase
x
because
direction, velocity will
no
not
external
increase because
force is there.
no external
Acceleration is
force
not
is
there.
there. Acceleration is not
Now,
there.
in y direction, we can apply
Y
second
direction,
equation of motion.
we
S
can
is equals to
apply
ut
second
plus half
equation
at
of
square.
motion. X is equals to ut plus half at
Okay,
square.
by applying that and putting
By
the
applying
time
that
t equal to x
and
upon
putting the time
v naught,
equal to x upon v
what we
naught,
will get?
what we will
We
get,
will get,
we will get.
yes. What do we get here?
Yes. What do we get here?
Hello, am I audible?
Hello, am I audible?
So you're audible, sir.
Fine. So we have imagined that initial velocity
So we
is
imagine that initial
v naught,
velocity is v naught,
and how much time it is taking to cover
and
this
how
whole
much time it
distance.
is taking to
If
cover
it
this
is
whole
in time
distance.
t, then this
If
t
it is
time will be
in time
distance
t,
upon
then this t
velocity.
time will be distance upon velocity.
Okay. This in this much
This
time,
in this much
it
time,
will be
this much
covering
time,
this y
it will be
displacement.
covering this y displacement.
Okay, in y direction. Therefore, in y direction, what
In
will
y
happen?
direction.
Initial
Therefore,
velocity
in
is
y
zero.
direction, what will happen? Initial velocity
Acceleration,
is zero.
we already
Acceleration,
know. This is the
we
acceleration.
already know. This is the
Displacement
acceleration.
in y direction is taken as y.
Displacement
Now
in
we
y
will
direction
apply
is
the
taken as y.
second equation
Now
of
we will
motion.
apply the
S is equals to
second
ut
equation of
plus
motion.
half at square.
S is equals to
U is
u plus
zero,
half at
half
square. U is 0, half
acceleration and square of time.
acceleration and square of time.
So here we are getting y equals to
Here we are getting y equals to
this much.
this
2
much.
into charge
2
E
into
upon
charge
2mv square divided by
upon 2 mv
x
square
square.
divided by
Okay.
x square.
In some books, in place of E, you will get
In
Q.
some books,
The
in place
expression will
e,
be
you
like
will get
this:
q.
2mv
Expression
naught
will be like
square
this: 2 v
into
naught
x
square
square. Got it?
into x square. Got it?
So this y is
Got it.
equals to
This
kx
y is
square. This
equal
is the
to
equation
kx square.
of
This is the equation
parabola.
What is that?
of parabola.
Okay, this is the equation of parabola.
This is the
Got
equation
it
of
now?
parabola. Got it now?
I got it.
Okay then.
Sorry, inbox आएगा ऐप को.
Okay then.
So ultimately, we are getting an equation of
Ultimately,
parabola.
we are getting
And
an
what will be the
equation of
final
parabola.
velocity? For final
And what will
velocity,
be the final velocity?
first find
For
out the
final
final
velocity,
velocity in x
first
direction.
find out the
That
final
will be
velocity in
same.
x
V naught is the
direction.
final
That will be
velocity
same.
in
V
x
naught is the
direction.
final velocity
And in y
velocity in x
direction,
direction.
again
And in
v
y
equal to u
direction,
plus at.
again v equal to u plus
Okay.
at.
So
Okay.
u is 0, a into
U
t.
is 0, a
This we
into
did here.
t.
And we got
This we did
velocity
here.
in y direction.
And we got
Therefore, what will be
velocity
the
in
total
y
velocity?
direction.
Total
Therefore,
velocity
what will be the
will be
total
under root
velocity?
of
Total velocity will be under root of
vx square plus vy square.
vx square plus vy square.
Under root of vx square plus vy
Under root of
square. Okay, got it?
vy.
And what
हाँ,
will be
got it.
theta?
Got it?
Theta will be
And what will be
tan
theta?
inverse vy
Theta will
by
be tan
vx.
inverse vy by v.
Here, one thing is clear to us
Here,
that this
one thing is
angle
clear to us
and the
that this
final velocity
angle and the final
both
velocity both
are dependent on
are
charge
dependent
to
on
mass ratio.
charge
See,
to
E
mass
by N.
ratio. See, E by N.
Charge to mass ratio. Higher the charge to mass
to mass
ratio,
ratio. Higher the
higher
charge
will
to
be
mass
the
ratio,
deflection.
higher will
Got
be the
it now.
deflection.
Theta will be greater
Theta will be greater
and y will also be greater. What is theta
and
and what
y
is
will
y?
also be greater. What is
This
theta
is
and what is
theta
y?
and this is
This
y.
is
Y is
theta
deflection and
and this
theta
is
is
y.
the
Y is deflection and
angle
theta
made
is
by
the
the vertical at the
angle
time
made
of
by the vertical
deflection
at the time of
Got it now,
reflection.
Hemant?
Got it now, Hemant?
Sir, got it, sir.
Anything to take down?
Anything to take down?
Sir, everything copied, sir.
Copied everything?
Copied everything?
Good then.
Copied, sir.
Good then.
Fine, good then. Take down this question and try to solve it.
Take down this question and try to solve
Okay.
it.
This is your homework.
Yes, sir.
This is
For the
your
given
homework.
arrangement in gravity,
For the given arrangement in gravity,
find the value of initial velocity for
find the value of initial velocity for
a charge of mass m
charge of mass
and
m
charge magnitude q such that
and charge
it
magnitude
does not
q such
strike the
that
plate.
it does not strike the plate.
Positive plate it must not strike.
Positive
Okay,
plate it must not strike.
solve it.
Okay, solve it.
Yes, sir, copied, sir. I'm sorry.
Copied. Okay, then that's all
Yes,
for
sir,
today.
Okay
copied.
then, that's all for today.
Yes, sir.